So right now, I'm going to talk about, electrochemistry. So that's our topic is, right? First, I'm going to define it. So it's electrochemistry. This is going to be the first lecture of this chapter. And what this is, the study of conversion of chemical energy into electrical energy and using electrical energy to bring about a non-spontaneous process. Okay, what this is something you have to understand. Though I'm again coming with something else in my mind, but I can't make you confused the way I am. What electrochemistry is, what happened inside a dry cell or a battery? There are chemicals stored. When you use them, actually the chemical energy of the cell converts into electrical energy. And what happens in a rechargeable cell, you provide external power to make the conversion of electrical energy getting stored in the form of chemical energy for some time. So there are two types of reaction. One, you use a dry cell where the chemical energy converts into a electrical energy, but you use a rechargeable cell also, where apart from this, another reaction is also taking place, which is the charging of the cell. So during the charging, the reaction is non-spontaneous because it needs external power. It needs external energy. So charging of a battery, charging of a cell is non-spontaneous. However, the discharging of a cell is a completely spontaneous process. So study of entire, these two phenomena together, this is what called electrochemistry. For you at least in 12th class, we have to get through. I was thinking, maybe I should also take redox from 11, but that's going to be, mess up everything. I hope I will make sure you understand. So I hope you understand that electrochemistry is the study of conversion of chemical energy into electrical energy and using electrical energy to bring about any non-spontaneous process. So what I mean here, that there the non-spontaneous process is a charging process. Let me write here so that you also mention your copy. Charging. This is about charging of cell. And there it's about discharging here. So I'm writing over there discharging. This also represents to discharging. Okay, I hope I have made it very, very clear. Now, in order to get through the rest of the thing, I hope you have started understanding what this chapter is going to be. So this chapter is mainly focused about electrical energy, conversion of chemical energy into electrical and vice versa. So I hope introduction is going to be interesting. What we need to start here is we need to start with a galvanic cell here. That's going to be the next topic here. So a galvanic cell. This can also be called, electrochemical cell also. But what this is, the cell convert chemical energy into electrical energy. And the first, galvanic cell that was designed was Daniel. So I'm taking an example here. Daniel cell also. So what a Daniel cell is, it consists of two container placed side by side. This one has a zinc electrode. It has a zinc electrode, and this one has a copper electrode. This is something also from the 11th. Okay, so they wipe this off because I hope you have copied in your notebook. So that's a zinc electrode. There is a copper electrode. These two have been connected with a wire. You can also place a switch or something. Switch here. Now this container is filled with zinc sulfate. Just to make sure you understand, you can easily see that this contain zinc sulfate solution and this one contain copper sulfate solution. So it's not like the copper sulfate is down here and zinc sulfate, it's everywhere in the solution. Okay. Now as the circuit is completed, what happened at this electrode where zinc is present, this zinc undergo oxidation. The zinc undergo oxidation. Zinc undergo oxidation, and once it undergo oxidation, oxidation refers to loss of electron, so it forms aqueous ion, and the two electrons are released into the solution. So what happened? Zinc is converting here. Zinc is converting here into the solution. So what happened now? Zinc had lost two electrons. These two electrons travel across the gradient here and comes into the solution. Those two electrons here comes into the copper sulfate solution. And there, the cuprous ion present in the solution undergo reduction by gain of those two electrons, and copper converts into solid form. So what is happening? Copper is depositing here. Copper is depositing. Right? So this reaction is called reduction half reaction. While this one is called oxidation half reaction. Oxidation half reaction. Now what happened after 1 mole of zinc has undergone oxidation and 1 mole of copper has undergone oxidation reduction? In order to continue the reaction, the charges has to be balanced between both of these, right? So the places where you see reduction taking place is represented by a positive sign, and this is called a cathode. This is called a cathode, and this one represented by a negative sign, it's called anode. Okay, so anode is experiencing dissolution of zinc into the solution, and the cathode is experiencing deposition of the copper on the electrode. So what will happen? This electrode will finally dissolve into the solution, but this will become more and more thicker. Now, in order to continue the reaction, a U-shaped tube has been placed here, and this tube contains, give me a second, I'm really bad at my drawing section. Okay, so what in here, there is a U-shaped tube here. This tube contains electrolytic solution, potassium chloride maybe. This contains electrolyte solution. And basically what this does, it produces two ions, potassium ion and chloride ion. Potassium moves into this direction while chloride moves into this direction. So these two ions present in this, this U-shaped tube, this tube is basically called a salt breeze. It's called a salt breeze. So what is the function of the salt breeze? It actually helps in balancing the charge between two half cell in order to keep the reaction going on. Function of function of salt bridge. Maintaining neutrality between the two half cell. Neutrality between the two half cell. Okay, that is the function of the salt bridge. How? By transferring opposite charges to respective sides. So what I've tried to make you understand that a galvanic cell, let me repeat back, consists of two half cell. These are called half cell. One has zinc, other has a copper. This one is filled in copper sulfate solution. This one is filled in zinc sulfate solution. When you connect these two electrodes with a wire and switch, and when you complete the circuit, what happens? Zinc being more reactive, it undergoes oxidation and it produces two electrons. These two electrons travel across the circuit, across the gradient, and it reacts with the cuprous ion present in the solution, and it converts into copper solid. So there you can easily understand there is gain of electron, which is also called reduction reaction, but now what we are calling reduction half reaction. This one is a oxidation half reaction here. And then in order to keep the reaction going on, we used a U-shaped tube, and which has a electrolyte solution, maybe KCl, maybe anyone. And actually what the solution has to do, it actually helps in balancing the charge normal so that the reaction can keep on going. So this is what the salt bridge function I have mentioned here. Now let's get with the another part here. Now the thing is that, overall redox reaction. Overall redox reaction. What you need to do? Oxidation half, which is zinc, produces Zn2 plus aqueous plus 2 electron. There is another reduction half. This produces, this undergo reduction Cu2 plus, which is in aqueous form, react with 2 electron, and it's converted into copper solid form. If you add both of them, what you need to do, you just have to add them. So if you add them, what happens? The electrons are going to be cancelled out. So there it remains zinc solid plus copper aqueous, and the products are Cu solid plus Cu solid, and this is overall called redox reaction. So I hope you have understood how a redox reaction is prepared using the half reaction. You just have to add them, right? So now what's the benefit of this overall process? When 1 mole of zinc undergo oxidation and 1 mole of copper undergo reduction, it generates a cell potential. You need to understand this symbol is called cell potential, and it comes out to be 1.1 volt, right? You need to understand that this is the potential difference of copper and zinc cell under STP. This is under STP, right? So this is what the first galvanic cell looks like. I hope I have tried to make you go through each and everything here. And what E cell is, let me repeat back here, because this represents to the overall cell potential. In this case, the cell potential was observed to be 1.1 volt, and this experiment is carried under STP. So this is the potential difference under STP. Okay, so somehow I've started with electrochemistry. I've started with galvanic cell. I've tried to define you, make you understand what these are, and I will take the coming sections in the next video. So right now